So it's nice to meet you all. My name is Idan. I'm the CTO of Hexadite, which is an Israeli startup founded 1.5 years ago. And our purpose is to narrow the gap that exists today between detection and response. If you guys heard about in the CISO panel that we just had, you probably heard some of the CISOs there saying it's hard for us to recruit, it's hard for us to train them. And the reason they want or looking for hiring 1,000 of incident responder or SOC analysts is because sometimes they don't even stop and think maybe we can just automate some of this process. So I'm gonna speak about why incident response is currently failing, and I don't think you will find one company that will say I have 100 success, I handle all my alerts, everything is perfect in my organization. I'm gonna give you a few reasons that you're probably familiar with why we think incident response is currently failing. And the first reason will actually be the complexity of the environment. As you all know, we have lots of assets to protect. Some of us has several hundred, some of us have several 100,000 of us to protect different operation systems, Windows machine, Linux machine, different kind of Windows machines, servers, databases, and etc. We also have a lot of users to protect and also to protect from. Some of them might be an insider threats. Some of them might just do, excuse me, but stupid things. For example, clicking on links that they shouldn't be clicking. And the latest one is actually tools. We have so many tools that we need to know how to utilize, right? We have firewalls, IPS, DLP, SIEM. So a SOC analyst or a cyber incident responder needs to be able to know how to interact with all those tools. How do I log into these tools? What is the username and password? And how do I perform all the operations that I want to do with those tools? So this is the first reason that incident response is currently failing. The second reason is actually our limited resources, right? You heard the guys before. It's very hard to recruit them because it's really hard to find them. And even if we do find them, and a lot of times they just leave us pretty early because they get tired of doing the same daily operation, which is usually, some of them is a bit boring, and the other one is just exhausting. So we got like a small team usually, a small SOC team usually. Sometimes some organization doesn't even have a SOC team. And other ones like big banks here in the US might have a large SOC team that need to handle a lot amount of alerts. So the SOC is usually overwhelmed by the amount of alerts, which actually causes alerts to go unhandled. And think about the SOC analysts, except for handling the alerts or the incident that they get on a daily basis, they also have the organizational bureaucracy, right? So they go to meetings, they answer phone calls, they send emails, they get ticketing systems. They need to do all that except for doing their work. So they can't really focus only on resolving incidents and quarantining and fixing incidents that retrieve from different sources. So all of those reasons together actually forces compromises. So as a SOC analyst, if I get 2 alerts and I can handle only one of them, I need to choose which one is more important, and that leads to prioritization. So I need to think, okay, I got this incident on this server or another incident on, I don't know, the CEO's computer, which one is more important? And then we start talking about, okay, what is the risk and what is the damage and how much, what is the business loss that can occur in each and every incident, and which also leads to alerts go unhandled. Okay, this is what I mentioned in the beginning. So the solution to what we offer in order to improve the incident response is called intelligent automation, and that's what I want to talk about in my presentation today. So the first thing that we believe needs to be done is to flip around the incident response process. And by flipping around, what I mean is instead of waiting for an alert to happen and then deciding what is the best way to handle this alert and then go get all the approval that I need from my boss or the CISO or the CIO, let's just try to think what incidents usually happens to us. How can we or how should we handle those alerts, and then come up with a plan, pre-approve this plan, so if something happens we can react fast and we don't need any further improvements, right? So We already have all the approval that we need. We already know what to do. We just need to do it. This will actually shorten the time much quicker than existing today. The second thing that we need to do is find a technology that once we have those plans, we can codify them into the system. So a system can take those plans and execute them automatically. So consider that you got an alert, you have a system that got this alert, understand what was the alert, has a plan that you know it should execute, and then executes it automatically. And I'm going to show you a use case or a scenario or a playbook, whatever you want to call it, in the future, in the later slide. So another thing that you can do with automation is forget about prioritization. We don't really care about it anymore. We're going to investigate everything. This is a new concept, right? I got an alert, I'm going to investigate it. I don't care where the alert is from, who is attacking me, and what is the risk. I just go and investigate it. This is something that we can't do with human beings, right? We have a team of 10 personnel. They can investigate this amount of alerts a day, and that's it. Well, an automated system is not really limited of how many alerts it can investigate on a daily basis. And an automated system doesn't care if you got 1 alert per minute or 100 of alerts per minute. It's going to investigate everything, and it's going to investigate everything in parallel at the same time. So if, for example, one investigation can take 5 minutes, and if it got 20 alerts at the same time, all of those alerts are going to take 5 minutes. We don't have multipliers here. Another thing is remediation. I'm not just talking about automating the process of the investigation itself. So we started investigating, we collected information, analyzed the information, and now we got to conclusions. Right? We found this malicious process that we want to terminate, or this malicious user that did something wrong that we want to block from the network, for example. So if we know how to do it, and believe me, those systems, all those security solutions that you're probably using today have some kind of APIs and can be integrated into an automated system, why not do the remediation automatically as well? So imagine that you can sit in a SOC or wherever you are. You know that alerts are being fired from different detection systems. There is a security solution out there that gets those alerts, investigates, and if it finds anything malicious, it's also doing the quarantine, everything for you. So the only thing that you need to do is just view whatever happened and see if you want to take another action or you're just fine with it. One of the advantages here is that everything that the system does, in opposed to a manual process, is documented, right? So if we got an alert, the system starts collecting information, touched different endpoints, did some kind of actions on each endpoint. We have full documentation on everything, so we don't need to pay those MSSPs or our SOC teams to sit after the incident is handled and then start writing the report, right? They can take them weeks to start writing a report, and they might miss something that they forgot that they've done, and we don't have any documentation of what was done. So this is also something that you can gain from automation as well. And consider that you can close the entire loop of getting the alert, investigating it, and do the remediation in seconds, minutes. Currently, it takes weeks. It takes days, weeks, months. Imagine that you can reduce this time to seconds and minutes, and I'm going to show you how it's done. Another interesting feature that you want your automated incident response platform to provide you with is actually, I don't want to call it machine learning, but some kind of learning to your network. So for example, if you as a SOC analyst got an alert, investigated it, and you did some kind of operation, the second time you're going to receive the same alert, you're already a bit smarter, right? Then you know what you've done in the past, and now you might do things a bit differently because you know what these alerts in the past looked like and what operation you took in order to solve that. So you would expect an automated system to act the same, so it can keep track of the alerts it got, keep track of how it resolved those alerts. So the next time you get an alert, it will be investigated smarter and more efficiently. And also you want a system that can adapt to your specific customized network. So this system an automated system can investigate and handle alerts in different ways. So for example, if the system wants to get all the connections from a certain endpoint, There are a lot of ways to do that. The first one is actually log into the machine and try to look at different connections. Another way to do it might be asking the firewall, right? So if you have, for example, a Palo Alto firewall, then you can go to the firewall and say who made this connection to a certain IP address. A third way to do it is using, for example, a log repository. So if you have a Splunk or a Hadoop or ArcSight logger, then you can just go to this logger and query this information there. So you would expect this intelligent system to use the same tools that you as analysts would have used in your network. So imagine that you have two different networks, but the same system is deployed in each and every network, but it acts differently in each network because it adapts to what you currently have. So if you don't have any other security solutions, and some customers might have, all they might have is an antivirus and a firewall, which is not very sophisticated and new generation detection or prevention tools. And others can have all those new capabilities of machine learning and behavioral analytics and all those security solutions. And you would want this system to use each and every security solution just like you would expect your SOC analyst to use. So a bit about times or timings. In the traditional IR process, there are three categories that we look at. The mean time to initiate is the time it takes you, once you get an alert, how much time it takes you to start acting or reacting to the alert, how much time it takes you to validate the alert, and the time it takes to contain. So in the traditional IR, the best cases that we've heard is it takes you minutes to start acting, hours to validate what just happened, and another few hours to contain. These are the best cases that we heard. What we expect to do with automated IR is get this entire process done in seconds or even minutes. So you look at different, you can see that time to initiate is seconds, time to validate might be minutes, and time to contain will be seconds as well. So we talked a bit about the benefit that we just talked. Investigate everything, forget about prioritization, forget about compromises. Be able to remediate events in large scale. So for example, imagine that you just got an alert that you have a ransomware spreading within your network, and you got like 100 or 200 different hosts being infected at the same time. As a SOC analyst, there is absolutely no way that you can investigate 100 computers at the same time. But an automated system can do it for you, which actually allows you also, when you respond in seconds and minutes, you also be able to minimize the potential damage. And I give you an example for that. So imagine that you just got, let's take the target case, for example. You got a malware deployed in one of your production servers, right? And the malware is sitting there waiting for a transaction to happen. So if it took you days or weeks to respond to this attack, the malware in the meantime got, for example, a million or maybe more credit cards and just stole and leaked this information out to the internet. But if you had a system that responded to this alert second after it happened or a minute after it happened, most likely this malware couldn't even steal one credit card information, right? So it couldn't react so fast to this alert. So this is another advantage of reacting fast to cyber incidents. Minimize the human intervention and also apply the best practices and policies. So for example, you can think that your SOC team has different playbooks that when different alerts happen, they do different things. But imagine that you can take your, let's say you have 10 people in your SOC team. There is one which is special, is the best SOC analyst that you ever saw. And you would want this SOC analyst to investigate all of your alerts, only this one with his capabilities. Then what the system can give you when you codified all this information into a system, then you know that for each and every action in the way of investigating an alert, you're going to take the best course of action. Because someone already thought what should happen on each and every stage, consulted with different customers, different organizations within the industry, different experts, and codified what should happen in each and every step. And you know that when you investigate an alert, you're doing it the best way that you can do it. So this is also another a big advantage of using automation. And most importantly, elevate your staff. We talked about those analysts that sit in a SOC and do daily operations. We don't want to waste their time investigating benign alerts. So usually if you get, for example, 100 alerts a day, usually like 80% or even more, it's going to be false or benign alerts. And it's really frustrating for an analyst to spend a lot of time investigating an alert and then just to find out that it was benign and just wasted his time. So if you can spare him this time, so let those analysts focus on the real, what you call APTs or the real advanced attacks, and take all the burden from them and put it in an automated system. And it also enables you to see how, for example, you have different solutions, different detection system that trigger different things, which is a good thing. I'm not saying that you should have a single solution to detect everything. It's a good thing to actually have different detection systems detecting different things. But what you do want to have is one single place or system that handles them. So you get alerts from different sources, but it's all coming down to a centralized system that investigates it for you. Then you can actually look at everything from a single pane of glass. Questions until now before we drill down to a specific scenario, which actually bring you some more insight about what I'm just talking about?
You could answer it later, but you mentioned about elevating the staff to higher value and not looking at false positives or false alarms.
Right.
So you have capability, you would be talking about a system that would have a capability to deal with the false alarms and note that they're false alarm and then close it out?
Yeah.
That's great.
It's a short answer, no, but that's what I meant, yeah. So it will actually do I'm not talking about, the biggest problem is getting an alert and only by looking at the alert saying whether it's a false positive or not, right? It's almost impossible to do it. You need to get more context, you get to enrich the information and see what's happened in the alert. But if the system will actually take each and every alert, doesn't care whether it's low fidelity alert, high fidelity alert, do whatever investigation, do the best effort that it can, and then find out that it's a false positive, you're going to get a report. Hey, this was the alert, this is what the system has done, the result was false positive. So the rest of the SOC team doesn't need to handle that anymore. They don't even need to look at that.
That's great.
Any more questions? Okay. So just to illustrate, I wanted to take a specific scenario, which is like, I think, one of the most common scenarios, and see how you would have done it currently, traditionally, manual incident response process, and then we'll see how much time it takes to do the same with an automated system. So the scenario starts when you get an alert that John's PC just contacted a known CNC server. Different solutions out there that can give you this kind of information. Some of them is IDS, for example, and other, for example, FireEye and all those kind of security solutions, which I'm sure you are aware of. So usually the first thing that you're going to do is begin investigating John's computer, right? So some of you might say, I immediately just disconnected from the network. Some of them is actually going to start investigating the computer while it's still in the network. So let's take, for example, the second case. So the first thing you want to do is just try to find out what is the connection origin, which process currently make the connection, is the connection still open, or is it something that happened in the past but you don't really see it. So let's say it was an easy case and you reacted very fast and you found and you located the process that made the connection. You see the connection open to the CNC server. So what you really want to do is first investigate the process, and it's going to take you a couple of minutes to do it. And then once you find the process that looks malicious, you're going to want to terminate the process, right? So let's, for example, say it was a Adobe Acrobat Reader, which had, for example, loaded a PDF file that had malicious content inside, and this Acrobat Reader actually contacted a known CNC server. So until now, what you've just done is you terminated the process, which actually is Adobe Acrobat Reader, and you want to look at the PDF file that was currently loaded and probably delete or quarantine the PDF file. So until here, this is the most obvious case that usually people would have done, or SOC analysts or investigators would have done. And usually they're going to end the investigation over here. So they basically did what they were expected to do, right? They got a connection to the CNC, located the computer, connected to the computer, find the process, terminated the process, and quarantine the PDF file. But let's say that this SOC analyst decided to take the extra mile and investigate the rest of the computer. So what it wants to do is actually look at all the running processes. Maybe there's another process. Maybe it's a dropper, for example, that just dumped another executable. Look at the services installed. Maybe a driver was installed to the system for a backdog. Look at recently created files on the disk. A persistency method, maybe some kind of rootkit or malware that installed something there that might load in the next boot. So we don't really know what this PDF or what the executable has done until we just got to the machine and quarantine it, right? It might execute a lot of things, and we don't really know what it was. And we look for persistency method. We look for any other connections that might have a connection to a CNC server or another other IP address that suspected to be malicious. And once we finish all that, which might usually take us a couple of hours if we are well trained and we know what we are doing and we have the right tools to do that, what we want to do next is actually generate leads, right? Maybe query the Splunk or the firewall for additional connections to the CNC server, so we can find maybe this malware was spread to another computers in the network. So once we find that, we might find other computers, which actually will take us days to complete the entire investigation. So this is a regular use case that happens all the time with different vendors. All of us, I think, suffer from connections to malicious IP addresses. And this is a really basic playbook that we can use just to elaborate what it will look like with an automated system. So let's take a look at the same process that will happen with an automated system. So the system got an alert, and the second after, it started investigating the John's PC computer. In order to locate the process that made this connection, it's going to take about 5 seconds. Investigate the process another 5 seconds, and then terminating it another second. So the entire process of just remediating the malicious activity that is currently going on, it's taking about 13 seconds to do it. So imagine that, let's say there is a hacker out there using Metasploit or any of those, created a PDF file, sent the PDF file to someone in your organization. Let's, for example, say you send it to your HR department, right? Saying it's a CV of an engineer that you want to hire. And one of the employees there just opened the PDF file. There was a connection to a CNC server because the PDF file had malicious content inside. And now the attacker now has, for example, a reverse shell or anything like that on the machine, and he can just start running commands, right? He can start do the reconnaissance. It can start gathering information about the organization, or maybe upload his own tools on the host to just keep persistency for the future operation that he wants to do. But imagine that an attacker just got the connection back from your host, your organization. In the meantime, you got this IDS or any other solution that alerted on this suspicious IP address, and the system after 13 seconds closed the connection. So imagine a human being just got the connection, he wanted to start doing something, but 13 seconds after, someone just terminated the connection. So as a human being, what you could accomplish in 13 seconds is not a lot. So the system will keep on going and quarantine the PDF file that made the suspicious connection. And then after that, it want to start looking at whether there's other things going on in the machine, right? So all what we talked about, running processes, running services, installed drivers, recently created files, open connections, and all that, it's going to be collected from the machine in parallel at the same time. So it will take him seconds, maybe a minute, to collect all this information and analyze that, and then go to your other log repositories, generate leads, find whether there are other endpoints that might contact this CNC server, and finally terminate the investigation or complete the investigation in approximately 1 minute. So this is the comparison between an automated system and a traditional IR in this simple scenario that we just explained. The difference is between 2 hours reduced to 1.2 minutes. This is the average case that we've seen from real environments. Any questions about the use case? All set. Okay. If you wondered how it really looks like in system that have those kind of playbooks or scenarios that need to investigate. It's not like a regular workflow, right? When you start an investigation, you know how it starts. You know what you want to look for at the beginning, but you don't know how it's going to end. So for example, an investigation can start by investigating a suspicious connection, and then jump to investigating a file or a process, or then finding other endpoints that might be infected and investigating those endpoints. So you can think of it like a decision tree that you as human beings, each step of the way, you need to make a decision, decide whether I want to do, what is the next step I want to do. So this should be codified into the system. And the system that you want to use should come with predefined playbooks in the system itself. So some of the organizations might already have those playbooks and they know what to do. Other organizations might not even have a playbook. What you do want to have is a system that comes pre-built with those playbooks. Maybe it will give you the possibility to edit them or configure them, change them a bit to what your demands as an organization and according to your policies. But you don't want to spend your time creating all those playbooks by yourself within the system. You want to maybe adjust them, but you don't want to start creating them from scratch. And there are many use cases that you can think of that can be automated. Okay, one of them is the scenario I gave you about a connection to a known malicious IP address. Another scenario might be that your antivirus just failed to quarantine a file, and now it expects you as a SOC analyst to succeed deleting the file. There are other scenarios, for example, phishing attacks. Imagine that you get, I speak with a lot of customers that have problems with phishing attacks that they usually open up a mailbox, phishing at this environment.com, and as employees in the network, you're expected to, if you get an email that you suspect to be a phishing or a spam, a phishing attack, you just forward this mail to spam@yourorganization.com. And there is some SOC analyst that sits there and get this alert and try to investigate it. So it looks for different words within the email. It looks for URLs. And if there are any URLs, it needs to be analyzed. If there's attachment to the email, they need to be analyzed as well. And then they need to go to the firewall or to the proxy, see whether there are any connection made to this URL or to the IP, and what if it was a drive-by infection, then maybe there's something downloaded to the endpoint. All those operations are very time-consuming. And I talk to customers that have phishing attacks on a daily basis, and hundreds of phishing attacks on a daily basis. So there is no SOC out there that can handle this amount of investigation at the same time if it's doing it manually, right? Investigating hundreds of phishing attacks daily, you need to have 100 people to do it. So none of what I just mentioned, all the steps I just mentioned that the SOC analyst would have taken cannot be automated. Parsing the keywords, looking for different things, parsing the URLs, investigating and analyzing attachments, all of those different use cases can and should be automated, so you can actually react to those incidents. I think that's it. So if you have any questions, I would love to answer them. Okay, well, yeah. Well, one of the recommendations that, let's say it like that, customers, let's face it, right? Customers don't want to hear another agent, right? Because usually customers have at least 4 to 5 different agents already deployed, and you don't want to have another agent deployed. So I would say it should be an agentless solution. You should look for agentless solutions. Our solution is an agentless solution. But on the other way, if you consider what a SOC analyst should do when you investigate something, if it just uses the same, open the task list and see which processes are running, it's clearly probably not the most safe way to do it, right? There are different rootkits and stuff like that that might hide themselves from different Windows tools. So for those advanced operations, you do want to use some tools to do that, like low-level tools that can access, for example, direct disk access or direct memory access. So the real solution that we actually came up with is a hybrid solution. That the solution is this agentless solution. So when you deploy it to your network, you don't need to install anything but a VM, no agent deployment, nothing. But when something happens, it starts gathering information remotely without using any specific tools. If you're familiar with Windows environment, that you can use WMI and WinRM for doing remote activities. If you're Linux-based, then probably you're going to use SSH, for example. But when the investigation gets to a point when it needs to extract information which is advanced, let's call it advanced operation, passing the MFT, passing raw memory, then usually what you want to have is a system that can deploy those tools, just like a SOC analyst can open up a network share, copy some, I don't know, usually a Mandiant tool, a Mir or something, extract a lot of information, then analyze them. The system will do exactly the same. So it will upload its own tools, run them, get whatever it needs, analyze them as well. Did I answer that? Yeah, go ahead.
You mentioned earlier about phishing. Does it have the ability to possibly create a list of users that would have received the phishing email, and then also create a list of users that would have clicked on the URL?
Well, it works a bit differently than what you just described. The way that usually it works is that you, as an organization, you have a mailbox, and users that get those phishing emails send those emails to this mailbox, and someone just reads the emails from the mailbox and analyze them. So the system actually replaces the person that reads those emails. So the system is going to have a mailbox,
Okay.
and those users are going to forward those emails to this mailbox, and the system is going to read it and act on that.
Okay.
Yeah.
Okay, I misunderstood. All right, thank you.
Okay, maybe I didn't mention a bit about how the integration works between the detection system and the system that needs to handle them. So there are different solutions out there, right? For example, antivirus, I'm guessing some of you have Symantec, some of you have Kaspersky, some of you have McAfee, some of you have Sophos. All of them send different types of, actually they're sending the same type of alerts, but in a different format. So for example, Symantec can send you a nice HTML table with the logo and everything, and McAfee might just send you a syslog or with just the information that is relevant. What you want is a system that can get those emails and extract only the objects that are relevant for the investigation. So when a system looks at an email, it doesn't care about the HTML, the font, and the logos and all that. It only cares about, for example, if we take the antivirus scenario, it only cares about the file path that was either quarantined or not by the antivirus, and the computer that the file was on, right? We don't need anything else to start the investigation. What we did in Hexadite, we actually work with a mailbox, and our system can get emails from different detection systems to this mailbox, and it knows how to extract these objects that we can run an investigation of them. So all you have to do is just get the alert that you usually get into your mailbox as SOC analyst, just forward them automatically to the system mailbox. That's all you have to do for the integration part. As for the other integration, for example, integrating with your firewall or with your log repositories to query information during investigation, for this kind of integration, the system has to use an API. So gladly for us and for you guys, all the systems out there that we ever used, for example, firewalls, IPSs, IDSs, SIEM solutions, all of them have some kind of API. Whether it's a SOAP-based API, RESTful-based API, and even if you just need to log into the database and extract the information from there. So you can do all those kind of integrations.
It seems like there's a real business case, and some of it's qualitative, meaning you can inspect everything, and you can decrease the cycle time. But in terms of the quantitative hard dollars, it seemed like you could definitely automate what people are doing. And you gave the example of phishing and how much time that would save. Are there a couple other things that come to mind based on the work that your firm has done, that these are some of the common things that save the most amount of time? If you could share them.
Yeah, so I think one of the scenarios that we encountered, I think it returned itself with all of the customers that we talked to, is actually the antivirus alerts. So it sounds pretty funny. We never thought it's going to be this way. But it turns out that usually in each company, there is at least one person that usually what it does the entire day is get those antivirus alerts, that says, for example, I'm an antivirus, but I just found a file with a bad reputation, right? And it sends the antivirus company sending a SOC analyst information about a file that has bad reputation, and now a SOC analyst needs to decide what I'm going to do with this file. Okay, so I already know that it has bad reputation, but I don't really know what else I can do with this file, right? Maybe I should upload it to another antivirus scans. Maybe it will give me different results. Maybe I need to put it in a sandbox. Maybe I need to check whether it's digitally signed by another company. So these are the kind of operations that an automated system can do very quickly, right? Get a file hash or get a file content, upload it to several different sandboxes, several different antivirus solutions, check against all kinds of whitelisting solutions such as NIST or Kaspersky or any of those, and then decide based on all of this information what I'm going to do with this file. I'm not going to expect the SOC analyst to decide. As a software security company, you need to make a decision. Either you want to quarantine the file or not, but you can't really let the analyst just do the operation. So we actually discovered that those kind of alerts happen a lot. And by a lot, I mean on a daily basis, like hundreds of times or several times or dozens of times on a daily basis. And usually what the user is doing is just getting those alerts, connecting to the endpoint, maybe uploading the file, investigating it a bit, and that's it. It's done. So what we do usually is we save a lot of this time for those analysts. So they don't really need to deal with this kind of alert. They only need to look at alerts that I usually get this question, so I'm going to answer it like one of you I just asked it. So, for example, there might be an APT out there, right, from China or from the US, it doesn't matter which one, which an automated system might not find. Okay, so for example, you might get an alert from FireEye saying, I found a connection from this endpoint to a known CNC server in China. And it might be a Chinese malware by the government. So the system goes, investigates everything, but it doesn't find anything because it's so sophisticated and zero-day. So it's going to show you the alert, right? It's going to show you, I got this alert, I investigated everything, and it turns out to be false positive. And you might say, as a SOC analyst, this is the part where maybe SOC analysts should start reacting. They got an alert, which is a high-fidelity alert saying that there is a malware in the computer, and on the other way, there's a system that's saying that it didn't find anything. So what an analyst would have done in this part of the investigation is see what the system has done, right? The system is going to tell you, I searched all the running processes, I looked for these kind of things in the memory, I looked for persistency methods, I tried to analyze the MFT looking for files. I couldn't find anything out there. So now you as a SOC analyst have two options. Either you are smarter than the system and you have other operations that you want to do. So let's just do that. If you are such an advanced user and you know how to do those kind of things, then focus on that. But if you don't, and you just want to, for example, take this machine out of the network, format it, re-image it, and bring it back, then you can do that as well. But what you don't want to do is those daily operations that I just mentioned that usually most of the time is become false positive. So actually save a lot of time, and eventually it makes the organization realize that maybe they don't need such a large SOC, right? Maybe they don't need 100 or 1,000 of incident responders. Maybe they need 5 or 10, right? So they will do only the work on those advanced targeting attacks that might attack your organization. Did I answer that?
Good, thank you.
Any other questions? Okay, guys, thank you very much for your time.